So you have learned how we can use hash tables or hash maps to solve programming problems. Now, going forward, we're going to dig in and see how these data structures work internally and why they're super fast. So earlier I told you that when we insert a key value pair in a hash table, this hash table will get the key, and based on this, it will figure out where to store this value in memory. Now, technically, we store these values in an array. So in more accurate terms, the hash table should map this key to an index value, the index at which we should store this value. This is the job of a hash function. So a hash function is a function that gets a value and maps it to a different kind of value, which we call a hash value, a hash code, digest, or just hash. Now, in the context of data structures, a hash function maps a key value to an index value. Let's see how that works. If our employee number or key is 1, we can easily store this value at this index. So if we have an array of items, we can simply set items of 1 to mosh, right? But what if this is a very large number? Let's say 1, 2, 3, 4, 5, 6, and we only have 100 employees. We don't want to create a super large array just to store 100 employees. Let's say our array has a capacity of 100 items. So we should map this number, this employee number, to a number between 0 to 99, because 99 is the index of the last item in this array, right? How can we do this? How can we map this number to this range? You learned that earlier in the course. We use the modulus operator. So we calculate the remainder of division of this number by the size of our array. So here's the simplest implementation of a hash function. Public static integer hash, which gets a number. Here we return number modulus 100, assuming that 100 is the size of our hash table or the internal array. Now let's test this. So let's do a print line, call the hash method and give it 1, 2, 3, 4, 5, 6. So if we want to store this value in an imaginary array of 100 items, we should store it at this index, right? But what if our keys were strings? So let's change integer to string, and we're going to add a hyphen followed by a letter. Let's say this is the employee number. How can we convert this to an index? Well, as you probably know, every character in computers is represented by a number internally. So we can get the numeric representation of each character, add them all together, and then we'll have a big number. Once again, we can apply the modulus operator between that number and 100. Let's take a look. So I'm going to change this to a string and rename this to key. And here we want to pass a string key, like this. Now we declare an integer, say to 0. Here we should iterate over this string. So for each character in this character array, we simply increment hash by the numeric representation of this character. So even though we are working with characters here, because we have declared hash as an integer, when we apply the augmented assignment operator between a character and an integer, this character will get automatically converted to an integer. This is what we call implicit casting. So after this for loop, hash is going to be that big number. Let's return it and test our code up to this point. So the hash of that long string is 419, but our array has a limit of 100 items. So now we can apply the modulus operator here and figure out at which index we should store this employee. Now, this is a super simplified implementation. There are so many algorithms for calculating hashes. Some of these algorithms are used in cryptography. For example, when storing people's passwords, we don't want to store them in plain text. So we pass them to a hash function, and this hash function will generate a long, complicated string based on that password. Something like this. This will be a hash value. Now, in the context of cryptography, this is not going to be an index value. This is just a hash value. But in the context of data structures or hash tables, this hash function should return an index value. This is where we want to store an item in an array. That's the basic idea about hashing. Now, in Java, every object has a method called hashcode. So if we declare a string here, this string has a method called hashcode. this method will convert the string into a hash value. Let me show you. So back to our main method. Let's temporarily comment out all this code. Here we declare a string, orange. Now we print string.hashcode. Look, we get this negative number, and obviously we cannot use this as an index value because here we're not in the context of data structures. We're not inside a hash table. This is just a numeric representation of orange based on the algorithm inside this method. So every object has a hashcode method. Now the hashmap class that we have in Java uses this hashcode, and then it does some extra work to map it to an index value. So this is all about hashing. Next, we're going to talk about collisions.